Well, so thanks to Christmas 2020 being an absolute balls up when it comes to deliveries, I've been waiting on the parts to do the Artemis board for a while, but finally this morning I have, oh yeah, so this took some doing trying to find this lot. It really did. Managed to get it all eventually on CPC, but various like capacitors, there seems to be, I don't know whether it's just through various supply chains suffering this year or not, but there seems to be a reduction in the amount of different values of caps you can get. Especially like switch mode power supply ones. I mean, manufacturers and stuff are a constant attempt to reduce manufacturing costs. The more of one value of component they can buy, the cheaper it becomes. And then of course suppliers respond to that. If you make 20 different values of something and 80% of what you sell is only 3 of those values, then you're going to concentrate on trying to get the cost of those 3 down more. So you're going to ramp up production towards them and probably just discontinue some of the other things you make, which then in turn causes manufacturers to buy them, and it's a cyclic thing. It's the way markets respond. So yeah, I did manage to find pretty much all the values I wanted or something I can substitute them with. So for instance, these caps here, this was the one that had the 1000 microfarad at 250 volt in it, just the one cap. I've managed to get some 330 microfarad at 250 volt. And how hard it was to just find anything other than just like one large cap to put in there with this voltage rating and something that would physically fit the board. I found some that were the values I wanted, but they were like short, wide ones, which I'm going to guess could be why I ended up with this one cap in there to start with. Maybe when it come to building the thing they had issues with supply. So anyway, I've got them. That was measuring quite weak. To be honest, these ones weren't measuring bad in the amp really when I took them out. However, the amp is, I don't know, nearly 10 years old I think. They've spent a lot of time baking in there, so I just went to and brought new ones regardless. Anyway, you just do. So yeah, and same again here, like I was saying in a previous video, it would have been easier. I could find like 250 volt values which would have done far better in there as single caps. However, they were too wide to fit the spacing. If it just been a row of 3, say 4700 microfarad 200 volt caps or something, I could have just got some dropped straight in. However, I did good. Look, these are perfect. So I've got them caps. As you can see, these ones are slightly, a lot of modern caps, way narrower, but the lead spacing is correct, and that's what's important. So yeah, I'm going to put them in there. I could have got some, there was some slightly bigger value caps, but this is part of an CLC, so capacitor inductive capacitor supply, smoothing supply. These diodes as well are only small diodes, asking them to charge up a couple of 1000 microfarads of capacitance all in one go. It probably would have blown them out. So every single capacitor on this board is being replaced. I've got all manner of various caps. Interesting, these are going to have the full AC across. A lot of people don't realise, just because a cap is rated at say 400 volts or something like these are by the looks of it, doesn't mean you can put like 230 volts AC across it. You know, you see people using a 400 volt cap across the mains. The electrostatic force is changing 50 times a second on the film inside, so it puts a lot of stress on the dielectric, and it's very easy. I've had it before, even like 100 nanofarad caps on a 12 volt AC supply have shorted within about 10 minutes. All of a sudden I've lost all my power supplies, I think I'm working on, and it starts smelling hot, and it's the capacitor shorted even though it was like a 63 volt cap. So these need to be caps rated for AC, so I'm changing these to some X2 rated caps. All of the coupling caps between stages I'm replacing. These cathode bypass caps I'm replacing. The cathode resistors for the output stage are getting replaced. The rectifiers, these, and where are there some little ones for the bias supply somewhere? They're all getting replaced. All the power resistors are getting replaced. So yeah, I've got plenty of work to do. More caps, diodes. So I guess what I'm going to do is I'm just going to slowly plod on, and to be honest, it's not a great deal to show when soldering stuff. It's just going to be me soldering the board, so I don't really going to bother filming a lot of that. I might just do little sections, but more interested in, once the things are all finished, actually getting the amp up and running, setting it up, and maybe just having a play about with some bits and bobs in it, just to see how it performs, do some power measurements and stuff. So yeah, that's all this video is going to be really. So what the next bit's going to be, who can say? I can imagine it's going to be some part of the board soldered up. So I've got to try and sort out these. The valve sockets aren't in great shape either. Ideally they could do replacing, but I might do some, yeah. So yeah, anyway, crack on, see how I get on. I'm gonna, yeah, these are for the heaters on the output valves, and you know, you just don't run AC wiring through circuit tracks for valve amplifiers. You point-to-point wire it, and to be honest, I might just do that. That might be a worthwhile mod to do. I think I will. I think I'm going to take the current off the board. I'll let it come in here still, because this is a humbucker arrangement, as it were. So as you can see, the heater supply comes on. There's an adjustable pot. You adjust it to just try and remove any heater induced hum. That goes, the centre pin goes to 0V. So I'll leave that there just for that, but I'm going to take the current. Heater supply is a voltage, isn't really an issue. It's the electromagnetic fields it induces as a current really, and there's a lot of current running through these. Yeah, I think there's 36 watts on each heater, so the two output valves are drawing 6 amps, and then these are going to be drawing an ever amp. So I'm at least going to take the heater supply for the output valves off of here, I reckon. But yeah, anyway, let's crack on and see what happens. Whew, what's that? 4 hours later, I think. 4 hours later. Yes, 4 hours. So, I've these heat. So this one was already fried. This was like this. I've actually tidied it up. This is better than it was, and yeah, it's incredibly close to that resistor which goes off to the grid of one of the output valves. But it is only 6.3 volts, but that is where the track ran. So meh, yeah. Anyway, so these ana resistors which were cooking, instead of having a single 3 watt 22k, I've now got a 10k and a 12k in series, making it 6 watts. But it works better than trying to shove a 5 watt in there because it's a bit tight. Some of these other resistors which were toasting replaced with 3 watts. All the coupling caps changed. The suppression caps across the diodes changed to X2 as they should have been to start with. The little 4.7 nanofarad bypass caps changed, and the caps going to the driver stage of the output, I've changed them to 220 nanofarads because I had some kicking about. I've made a mod, not the tidiest in the world, but it dawned on me, if I get the, when I was looking, so the bias on the output stage, valves need to be turned off, not on, so the voltage needs to be pulled negative with respect to the cathode on the grid. And these, the connection to the grids via this, so the anode capacitors from the previous stage connects here and here, so this presents a high impedance path to the bias network. If this pot goes open, there's no bias on the output stage, it will go into full-on flat-out runaway. But likewise, that pot also connects via this little, so if those wires break, which is highly possible, again, these resistors connect to that pot via them wires, it can go into runaway. So I've put in some 470,000 ohm resistors, one here, we got a new camera, one here, and now it's trying to focus on the background because camera. Come on, thank you. I've put one here and one here, no, one here and one here. They sit at that point just there, and then they connect straight to negative rail. So that means if the pot goes open or this connection breaks on this piece of wire, the valves will go to the lowest bias they can have, not the highest. You can see like little things like the capacitors. You can see these are actually higher voltage rated than what was on here before, considerably smaller. These are little dinky little ones, they're all dinky on there. I've replaced these diodes, put some 5 watt resistors in the cathode bias network instead of the 3 watts that was in there. Changed the caps. So like I say, yeah, I've bolstered some of these. I was thinking about point-to-point wiring them, but I've put enough into this. So I've bolstered up the connections on these to at least make it so there's a much bigger contact patch where they connect. If that had been done to start with, this would have never happened. I still really don't like this, but I mean, I can get my nail in between it, and there is negative voltage on that to whatever the valves need, so maybe 30-40 volts, which I don't like, especially with the fact no one cleaned, the previous person who didn't clean off the carbon tracking, so I'm going to try and do that, because carbon is conductive, oddly enough. So yeah, the only thing left to do now is to start putting it back into the case and then balance the AC output to the output valves. There was a couple of caps on this that were mounted to the underside of the board, this being one of them, this being one of them. Now there's a heater rail runs in between there and it runs both sides of this one, so I figured that's why they've done it. But the underside of the board gives you a millimetre or so, whereas me, oh, I'm way off camera, me lifting these up give me far greater room, so I've mounted onto the top side. However, I'm now wondering if this one was actually mounted to the underside of a focus. Come on, focus. What are you focusing on? Yeah, come on, thank you. I'm just wondering how this much room this thing needs. Does it sit up here like this, or is it going to foul on that cap when I try and put it back in the case? So I might end up having to remove it. I shall find out shortly. Yeah, as always, fantastic super dodgy camera work from me. Time for a cup of tea before I progress any further. So like I said, that is 4 solid hours. Yeah, so basically the only thing that hasn't been changed is resistors which aren't particularly stressed. Anything that's got large amounts of DC current, all of these are just like bias resistors, cathode resistors, milliamp or so in them. You know, you got at some point you got to call it a day. So yeah, see if it will fire back into life. There was a lot of damage actually, I forgot to mention. So this is how much damage there was on the bottom of the board. This is from the factory. This rail coming around here is actually a 0 volt rail, and you can see it's cut. It was connecting to here. Well, this is the anode from the previous valve. So this connection here that goes off to the grid, to the output valve. I can't show you. So if there's the grid from the output valve, you cold it, follow it back. It goes to here, and this here is meant to be the anode coming from the driver valve. For some reason they connected the anode to 0V, so they cut the track and then they put a real dodgy piece of just component leg in there. So I took the opportunity whilst I was putting these new resistors in, right there, to just bend the leg right the way through and connect it. So that's one solid connection all the way through the top place of the board. This was completely burnt up here. You can see that was gone. The track had burned off the lot of the pad, so that's actually several component leads coming through. It's where that resistor and that resistor all joined together. So it's all the legs from them are joined together. Some damaged pads which was burnt, so I've took the liberty of just scraping a bit of track off, bending the leg over, or soldering the leg onto the next one. And again here, this one was completely burned off and gone. You can see it's black and crusty, so it solders onto the next component round the corner, and then one here. No, that's actually, I've scraped off a bit of track there. It's soldered to a bit of track I've scraped, and then onto the next component. Gone round, all resoldered all the connectors, these crusty ones. Look, that's that burnt one there, nice and crusty. Everything's an absolute arse to solder on this. Let's see if I can pick it up on the camera. If I turn it that way around, you might see it better. See that like yellow discoloration? This, it comes from a very heavy smoker's house. It's left on a lot. Took me a while to figure out why I was having issues soldering. It turns out everything is just absolutely covered in nicotine and tar, and you can smell it on your fingers when you try and solder it. The smoke coming off this thing, it is acrid, nasty. Makes me kind of feel like I want a cigarette. So yeah, anyway, that's the board up to this stage. Like I said, that's took 4 hours. Isn't progress a wonderful thing? So yeah, I've been banging out the Christmas hits on Radio 4, because like, it's Radio 4, so do you know Radio 4, innit? So yeah, anyway, let's say cup of tea time. Next bit should hopefully be this back in the amp and ready to hit the power switch. Okie dokie, so several hours later, about another 3 hours later actually, it's upside down, it is running. I accidentally touched a capacitor. These capacitors, because they're in parallel, float, and like for instance these ones here, look, that's gone off the scale. Where is the scale? So that one's there. 266 on that one, these are the negative for the bias. You don't touch the tops of them with your fingers, because the negative of the capacitor is the outer shell. Yeah, that was fun. Luckily enough, I was the old one finger technique, the other one touching nothing, so it hurt, but it didn't kill me. That's why you try and go in with one hand. Anyway, so yeah, just biasing them up. I don't have the lead to plug into the bias checker, so that's why I've got the amp upside down. What am I at? Yeah, see, these valves took some waking up. It's hard to you adjust and things settle and change, and it takes a few attempts, but interesting, this valve on this side is quite weak, because if I measure the bias on this valve, see I'm minus 72, this one minus 90. I'm getting the same amount of current through each valve, but with 20 volt difference on the grid. That valve is weak. Here's rather interesting, there's a 450 volt capacitor here. Should I move you in a bit nearer? So this capacitor just here is 450 volts. So there's the HT supply for the triode stages, the two input valves. Unfiltered, raw, at the first filtering stage, it's 536 volts. 3,300 ohm resistor for a secondary filtering. 458 volts. Well, that cap's only rated at 450 volts, so it's no wonder the other one died pretty quick. That should have been 2 series caps as well, but manufacturers for you, man. And then there's some additional smoothing. I've not actually measured these. See, look, these as well. These are 450 volt caps, and they are running hot. So, yeah, no wonder the bloody thing has so many dried up caps in it. So yeah, anyway, it is working again. I shall turn it the other way up, connect the speaker to it, and prove that. And yep, someone's just letting me know there. They agree with that's a good thing to be doing. Well, there it is. Look at that. Will she focus? Can you focus? I should probably go to manual focus. Oh no, there we go. Oh yeah. Narrowed field of view there. Hi. So yeah, huge amount of work on this one. Damaged PCB. That mod I did on the bias turns out, I took it off in the end because you just couldn't get the bias to go high enough. Sod it, they build it like that, it can stay like that. If it was mine, I'd have modified it some more. It needed additional circuitry putting in for that mod to work. But yeah, and so if I press play on the YouTube board, look, the cable comes out to the telephone and goes into the back of the amp. If I press play on the YouTube, obviously they're monoblock amps. The other one's mirror image of this. I've only got one speaker running, but hell, man, it's incredible. It uses no negative feedback at all. None of the stages run any feedback to any of the other stage, and there's no hum. Huge amount of filtering and inductance on the power supply. The thing runs like an absolute heaven. So what are these dissipating? 120 millivolts over a 4.47 ohm resistor, so 250 milliamps or so at 200 odd volts. So Anna, you do the maths. 30. I'm gonna have to do the maths. Let me do the maths. Phone in pocket. I'm not even gonna stop the camera rolling. Should we have a look? Let's have a look, shall we? We have 0.12, so it's 120 millivolts of bias over 0.47, 255 milliamps through the valve, and then there's 230 volts across it. Oh, look at that. So yeah, there's 60 watts dissipation on these two anodes, 60 watt on these. Then the heaters in these run about 40 watts each, so each one of these valves is dissipating 100 watts, and then a small amount being used in these and the circuitry inside. So yeah, drawing probably 130 odd watts or so off the mains just to do nothing, just to sit there. Well, yeah, it's worth it. Do you think if I send the owner my little workshop amp down there, he'll notice the difference? Yeah, I don't think he will. I'll be like, no man, no, there was always that small. Totally. Reminds me, I really must get round to getting myself a big ass valve amp built. It's time, man. I get time off from my full-time job, and what do I end up doing? I end up working, fixing stuff for people that I've promised them I will fix when I have time, and all of a sudden I'm like, oh, I'm off over Christmas for a fortnight, I've got time to fix your amp for you. And the work comes thick and fast. DMX boxes, amplifiers, CD players, bloody what's the word, balance line audio splitters and motorcycle bits that I need to change, and before I know it I'm back to work, and all I've done is work. But hey ho, it's how you earn money, isn't it? So yeah, that's it. Just look at that. Should we turn out the lights? Oh yeah. Yeah, it is working, so that'll do, pig. That'll do. As always, thanks for watching, and catch you next time.